Hello all, welcome to the Counting Bell RMS Prep live session. We know that the baseline for RMS, that is Ramanujan Math Scholarship, is already released and we have the final assessment test on 30th April. How to participate? You just have to complete the course in step 1 of the RMS in order to qualify and take the scholarship. The course is designed to help you fill any learning gap from previous academic year and get you prepared for the new class. So we are here to help you qualify the scholarship. For this, stay tuned to the session and get ready for the test. Before we move towards our chapters, let us see some of the problems or the doubts posted by our app users. The name of the students are as on the screen: Akanksha, Shelke, and J. Gokul. So Akanksha is from Poddar International School and she has doubt on finding the value of variable, that is the solution of linear equations. Then J. Gokul is having doubt on simple equations. J. Gokul is from Lakshmi Garden School. So both of you just stay tuned to the session as we are going to clear your doubts while we are revising this previous knowledge concepts from the chapters mensuration, algebra, ratio and proportion, and geometry. Let us start with the chapter mensuration. What is rectangle? First of all, it is a four-sided polygon in which opposite sides are parallel and equal to each other. Now, finding the perimeter of rectangle, the formula is 2 times length plus breadth. So once length and breadth are given, then you can multiply 2 into length plus breadth. So this is how you can find the perimeter of the rectangle. Now, let us find the perimeter of a rectangle whose length and breadth are 25 meters and 15 meters respectively. If length is 25 meters and breadth is 15 meters, perimeter is 2 into length plus breadth. So you just have to substitute the values of length and breadth here. So you have 2 times 25 plus 15, which is 2 times 40, which is 80 meters. So in this way, we can find the perimeter of given rectangle when the length and breadth are given. Now, let us use the formula to find the area of rectangle. We saw how to find the perimeter of a rectangle. Let us see how to find area of a rectangle. So area of a rectangle is nothing but length into breadth, and area of any figure is measured in square units. So it can be square meters, square centimeters, and so on. Now, let us use the formula to find the area of a rectangle. Let us find the area of a rectangle whose length and breadth are 12 centimeter and 4 centimeter respectively. The length of the rectangle is given as 12 centimeter, breadth of the rectangle is given as 4 centimeter. So area of the rectangle will be length into breadth, that is 12 centimeter into 4 centimeter, which is 48 square centimeters. So area will be 48 square centimeters. Now let us solve this problem. The lengths and breadths of three rectangles are as given below: 9 meters and 6 meters, 17 meters and 3 meters, 4 meters and 14 meters. Let us find which one has the largest area and which one has the smallest. For this, what we have to find first, we have to find the area of these three rectangles. Now, area of the rectangle is length into breadth, which is 9 into 6. You just have to multiply the length and the breadth, which is 54 square meters. Next, finding the area of the rectangle having length 17 meters and breadth 3 meters. So it is 51 square meters. Next, we have area of the rectangle having length and breadth as 14 meters and 4 meters. So the area is 56 square centimeter. Just note down the areas of the three rectangles, 54, 51, and 56. Which one is the largest area? Which one is the rectangle having largest area? It is nothing but the third one. So the one given in the C subpart is the rectangle having largest area, whereas the one given in the B part of the question is having the smallest area. Let us start off with the chapter algebra. Let us know what is an algebraic expression. So algebraic terms, before going to expression, we have to see what are algebraic terms. They are nothing but terms with variables and they can take different values depending upon the value of the variable. Whereas constant terms are just numbers and have a fixed value. If we combine the terms with mathematical operators, okay, then they will make an algebraic expression. Let us see some example. So here you can see we have an algebraic expression. In the statement, we have two quantities. Okay. So let us first see what are the two quantities. They are 3x and 7. Each of these quantity is called term. Okay. And if a term has a variable, then it is an algebraic term. And if the term is just a number, then it is a constant term. So which one is algebraic term among these two and which one is constant? Yes. 3x is an algebraic term, whereas 7 is a constant term. Let us identify all the terms of the expression given below. In the expression 3a plus 2b minus 11, there are three terms. Which are those? 3a, 2b and 11. Let us understand the solution of an equation. What is solution of an equation? In an equation, when we substitute the numerical value for a variable, and if that value is like it is same on the LHS and RHS, then we can say that the value satisfies the equation or it is a solution of the given equation. For example, let us consider the linear equation 5x plus 12 equals to 27, where x is equal to 3. What we are going to do, we are going to substitute x equals to 3. So 5 into 3 plus 12. So this will be LHS, which is 27. You can see the LHS is equal to RHS. Both are equal to 27. So what we can see, the value on the left hand side, that is LHS, is equal to the value on the right hand side, that is RHS. Hence, x equals to 3 is a solution of the equation. This also means that the equation is satisfied for the value x is equal to 3. What this means, x is equal to 3 is the solution of the linear equation 5x plus 12 is equal to 27. Let us put the value x is equal to 2 in the equation and check. So 5 into x plus 12 is nothing but 5 into 2 plus 12 when we substitute x is equal to 2. So we have 10. 10 plus 12 is 22. And you can see the RHS is 27. As 22 is not equal to 27, that is LHS is not equal to RHS. The value on the left hand side is not equal to the value on the right hand side. Hence, x is equal to 2 is not the solution of the equation. That means the equation is not satisfied for the value of x is equal to 2. Let us understand the solution of an equation. Let us use trial and error method. Let us consider the equation p minus 9 is equal to 2. Let us find what value of p satisfies the equation. Let us make a table and take the different values of p and find the result in each case. We write the values on the LHS in the second row of the table. So you can see in the first row we have values for p. In the second row we have p minus 9. So let us take the values 1 to 11. So if we substitute p is equal to 1 in p minus 9, so we have 1 minus 9 which is minus 8. If we substitute p is equal to 2, then we have 2 minus 9 which is minus 7. Then we have 3 minus 9 which is minus 6. 4 minus 9 which is minus 5. 5 minus 9 which is minus 4, and so on. So in this case, we can see LHS is not equal to RHS. When P is equal to 1, it is minus 8. So minus 8 is not equal to 2. So we have to find for which value of P minus 9 is equal to 2. Yes, you can see in the last value, you can see when P is equal to 11, P minus 9 is equal to 11 minus 9, which is equal to 2. So in this case, LHS is equal to RHS. We can see that 11 is the solution to the given equation. This method of substituting different values and arriving at the value which satisfies the equation is called trial and error method. Means we are doing some trial and errors. We are randomly substituting the values starting from 1, and we are keeping the different values for P and getting the RHS as 2 or not, we are checking. Now, to check whether the given value is a solution for a given equation or not, we are going to follow this step. First step is to substitute. We have to put the value of the variable in the statement. In the next, we have to calculate the value of the expression on the LHS. Then we have to check is the value on the LHS equal to the RHS. If they are equal, then the value is a solution. If they are not equal, then the value is not the solution. So in this way, we are going to check. Let us see one example. Let us check whether x is equal to minus 3 is a solution of the equation x minus 3 is equal to 0. So we substitute or we put x equals to minus a, which will get minus 6. As minus 6 is not equal to 0, so x is equal to minus a is not a solution of the equation. Now let us find the value of p which makes the statement given below true. We have one equation 2p upon 7 is equal to minus 4. If we substitute p is equal to minus 14, what will happen? Let us see. So once we are putting minus 7, this will give you 2 into minus 7, which is minus 14 divided by 7 is equal to 2. So that is not where we are getting LHS is equal to RHS. So we substitute p equals to minus 14. So if we put p is equal to minus 14, we'll get 2 into minus 14, that is minus 28, divided by 7 as minus 4. That's why when we are having P is equal to minus 12, LHS is equal to RHS. So when P is equal to minus 14, the statement becomes true. Let us move towards our next chapter, which is ratio and proportion. So when can we compute a ratio? It can be computed only when the two quantities are in the same units. And ratios are usually written in lowest terms. So let us see one example. If one store has 360 number of items and another store has 100 of the same items, let us express the ratio of the items. We compare the two quantities in the ratio notion as follows. 360 upon 100, or it can be written as 360 is to 100. As we are writing ratio in the lowest terms means we are dividing by common factor. So the highest common factor is 20 here. So what is the largest number you can divide both the quantities by? I expect this answer from you all. We are dividing by 20. So we are getting 18 by 5, which is 18 is to 5. So this is the ratio in the lowest term for 360 is to 100. Two quantities may not be in the same units. In that case, we need to convert them into same units. This is when the units are different and you are expressing one quantity in terms of the other. Finally, we need to reduce them to their lowest terms. And this form of ratio is called the simplest form of the ratio. Ratio has no unit. You have to take care of this statement. Ratio has no unit. As you're dividing the two quantities, okay, and the two quantities may not be in the same units. So you're converting them into same units. That's why the ratio will have no unit. Let us see one problem. A bag contains 5 kg of rice. 1,500 grams have been taken out for cooking. Let us find the ratio of the amount taken out to the amount left in the bag. The two quantities are not in the same units, therefore we have to convert them into same units. So 5 kg we have to convert it into grams, as the total number of grams taken out for cooking is in grams. So we are converting 5 kgs into grams. We know 1 kg is equal to 1000 grams. So we have 5 kg is equal to 5000 grams. What is the amount left in the bag? It will be 5000 grams minus 1500 grams, which is 3500 grams. So the required ratio is 1500 is to 3500. So we are dividing by the highest common factor and we are getting the ratio as 3 is to 7. This is the simplest form of the ratio or the lowest terms. Let us see the chapter geometry now. Understanding what is perpendicular bisector of a line. A perpendicular bisector of a line segment is a line perpendicular to the line segment and bisecting it. So in the name itself, you can see a perpendicular bisector is nothing but, first of all, it is a perpendicular line segment, and next it bisects the line segment. For example, consider the line segment AB. Bisector means it should divide the line segment into two equal parts. Hence, we are taking a point P here, which will divide the segment AB into two equal parts. So we have here two equal parts, AP and PB. Now, as we can see, P is the midpoint of the line segment since P is dividing the line segment AB into two equal parts. Let us draw a perpendicular to AB through the point P, and that perpendicular we are naming it as MN, and it should make an angle 90 degree with AB. So we can see MN is perpendicular to AB. Since MN is dividing the line segment into two equal parts, or we can say it is bisecting the line segment AB, MN is known as what? The perpendicular bisector of the line segment AB. Let us move towards our next concept, which is identifying the type of angle based on the measure. To identify the type of an angle, we have to compare the angle with a right angle. Means whether the angle is less than a right angle, or it is greater than right angle, or it is exactly equal to right angle, or it is more than a straight angle. So let us see one by one. If the angle is less than a right angle, it is acute angle. And if it is more than a right angle, but it is less than a straight angle, then it is an obtuse angle. And if the angle is exactly equal to right angle, then it is a straight angle. If the angle is more than a straight angle but less than a complete angle, then it is a reflex angle. Let us see a problem where we have to identify the type of angles in each of the following. You can see here two figures A and B. Let us identify the type of angle in figure A and figure B. You can see polygon A has all angles in exact shape of L. Hence, they are all right angles. So here you can see it looks like a square and it has all the angles as right angles. Whereas angles in the polygon B are all less than right angle. Hence, they are all acute angles. Let us see one more problem. In the figure, we can identify the type of angles A and B marked in the figure. A angle is more than a straight angle, but it is less than a complete angle. Means it is more than a right angle, but it is less than 180 degree. Hence, it is a reflex angle. Whereas the angle B is more than a right angle, but less than a straight angle. That's why it is an obtuse angle. Okay. So this is how we have identified the type of angles A and B. Now let us identify the triangles based on the sides. You have to check the lengths of the three sides. If all the three sides have same length, then it is equilateral triangle. The name itself says equilateral means equal sides or equal length of the sides. If two sides are equal in length, it is an isosceles triangle. Means only two sides, only the length of the two sides are equal. If all the three sides are of unequal length, then it is a scalene triangle. So depending upon the length of the sides, you have to identify whether it is an equilateral triangle, an isosceles triangle, or a scalene triangle. In the given triangle PQR, length of sides PQ is equal to RQ. Let us find what type of triangle is triangle PQR. Let us see the solution. In triangle PQR, two sides are equal. Correct? because it is given PQ is equal to RQ. So it is an isosceles triangle. Next, let us identify what type of triangle is triangle XYZ, in which the measurements are XY is equal to 4 centimeter, XZ is equal to 4 centimeter, and YZ is equal to 4 centimeter. What this means, all the three sides have equal length. Hence, according to the measures, all the sides are of equal length. Hence, the triangle is nothing but an equilateral triangle. To identify the triangle based on angle, triangles can be identified based on both sides and angles. We have seen how we are identifying based on sides. Now we are going to see how we are going to identify based on the angles. Whether it is scalene acute angle triangle, isosceles right angle triangle, or isosceles obtuse angle triangle, etc. Now, let us look at this problem. Let us identify the type of triangle by observing the length of the sides and the type of the angles in it. So what you're observing, triangle PQR, which is 90 degree at Q. PQ is equal to 6 centimeter, PR is equal to 8.5 centimeters, and QR is equal to 6 centimeter. In the given triangle, you can see PQ is equal to QR. That is, two sides are equal. Hence, it is an isosceles triangle. Also, one of the angles is a right angle triangle. So here you can see the angle Q is 90 degrees. Hence, it is a right angle triangle. So we'll combine the isosceles and right angle and write it as right angled isosceles triangle. So this is a proper way of identifying the type of triangle based on the angles as well as the sides. I hope this session was helpful, and after RMS, that is scholarship test also, if you want to continue to use counting well, to keep learning maths, practice and improve your scores and develop good problem solving skills, then you can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well. So gear up and complete the course at the earliest to qualify for the final scholarship test. At the end of this session, I just want to wish you all the best for RMS. We will see you in our next session. Until then, keep learning and keep growing. Thank you.